So the next concept is edge trigger D flip-flop. So in the previous video we have discussed regarding like D latch. Okay, this was a gated D latch we had discussed. We look after the waveform and characteristic equation, truth table of gated D latch we did in the last video. So now I'm going with the edge trigger D flip-flop. So far we have discussed regarding flip-flops, latches. Now we are going to deal with the flip-flops. What do you mean by flip-flop? What is the difference between flip-flop and latch? The first thing is the one major difference between a flip-flop and a latch is this flip-flop is going to work with respect to the clock, and the latch is going to work with respect to the data input. Latch, the output of the latch is going to change just based on its input. Okay, it never considers clock. There won't be a clock input pulse for the clock. Okay, sorry, for the latch. But when it comes to flip-flop, if the output need to change, means that has to be changed only with respect to the clock pulse. Okay, when the clock pulse changes, then only the output changes based on the input given. So that is what the flip-flop is going to work. Let me explain here. So look at this clock. Okay, we have two types of edge. This is edge trigger D flip-flops. We have two types of edge. One is positive edge trigger and one is negative edge trigger. Okay, what is positive edge trigger and what is negative edge trigger? So this is a clock pulse I have written here. So look at this. This is low, this is high, this is low, this is high, this is low, this is high. Okay, so this is low waveform. This is moving from 0 to 1 and 1 to 0, again 0 to 1, again stay. This is 1. Okay, again moving from 1 to 0, again 0 to 1, like this. Okay, the pulse will be the clock pulse will be moving like this. Okay, this, when the system changes from 0 to 1, that is low to high, this edge, this time moving from 0 to high, 0 to high, I call it as a positive edge trigger. If the system changes its state during falling edge, this is, I call it as a rising edge, is a positive edge trigger, moving from 1 to 0, like this downwards, falling edge, this is a negative edge trigger. If the system changes its output based on the clock pulse, if the system changes during the positive edge trigger, moving from 0 to 1, so then it's a positive edge trigger. If the system changes its state during the falling edge, like this, from 1 to 0, I call it as a negative edge trigger. Okay, so in case of latch there was no clock, and in case of flip-flop we come across clock pulses. The system need to change whatever the changes that appears with respect to the next state. Based, we give 0. If the 0 need to change to 1 or 1 to 0, whatever the changes that has to happen only during the positive edge trigger or negative edge trigger, during either the rising edge or falling edge. It has to take this clock pulse into the consideration before performing its operation. That is what we call as flip-flops. Okay, so this is a clock pulse. Normally we represent like this, an arrow mark like this, clock. Okay, this is a positive edge trigger. If we have a bubble just below this arrow, so this is a negative edge trigger. This is a positive edge trigger flip-flop, this is a negative edge trigger flip-flop. Only the difference is we had a bubble here, there is no bubble here. So that's the difference. Okay, look at this. There is no bubble here. This is I call it a rising edge trigger. There is no bubble here. Rising edge means, so system changes when it is rising, like this, rising edge. This is a positive edge trigger. This is a falling edge, means we will come across a bubble here. Falling edge means when it is moving from downwards, like this. This is falling edge. Moving from high to low is a falling edge. Moving from low to high is a rising edge. This is a rising edge. Okay, this is what they are given. Hope you remember the D latch. So how the D latch was working. So whatever the input, D input is 0 means the output will be 0. If input is 1, the output will be 1. Okay, that's it. So if D is 0, this is a Q refers to present state or previous state. This is a next, Q plus refers to the next state, right? I am going to pass 0. Okay, the output will be 0. I am putting 0, output will be 0. I am passing 1, the output will be 1. I am passing 1, the output will be 1. whatever the input you're going to pass, the same thing will be the output. So no matter whatever the present state it might be, this is how the D flip-flop or D latch is going to work. Okay, here we have a waveform. So look at this waveform. You will come to know how this change of state occurs with respect to the clock pulses now. So look at here, D right now, what is the value of D is 1. Okay, but what is the value of Q? 0. Why it is 0? So D here is 1, but the value of Q is 0 here. So the 1 which is given as an input for D should apply to the output Q, right? But it has still 0. The output will changes to 1 only after the clock pulse. This is a falling edge trigger. Falling edge means negative edge trigger. So the system changes during only the falling edge. See, look at this clock pulse. This is a falling edge. So we have falling edge. Once the falling edge occurs, then the system will take the D input into the consideration. So when the clock pulse falls, so what is D here? 1, right? 1. So Q will change from 0 to 1 now. After some delay, Q changes to 1. Okay, then after 1, Q changes 1, D will changes from 0. The D input now 1 will replace with 0. But immediately it won't be applied to Q. Again it will wait for the clock falling edge. Look at here, falling edge is here. Once the falling edge is here, look at this will be 0, then this input will be applied to Q. After the clock occurs, then only the input will be passed on to the output. Immediately won't apply. So look at here, then D is 1 but Q is 0 right now, but it will wait till the clock falling edge occurs, like this. Falling edge occurs. Once the falling edge occurs, what is 1? So here it is also 1. So Q will change from 0 to 1. Again for the next clock pulse, falling edge, D is still 1, so it will continue to 1. Again look at this next falling edge, D is 0 here, so it will change to 0. So the thing is, whatever the input you are going to pass with respect to D, that will be applied, that will reflect to the output Q only after the clock edge occurs. Either it may be positive edge clock or it might be negative edge clock. So this waveform represents the change of state occurs during the falling edge. So we need to concentrate only the falling edge. The changes occurs only after the clock pulse falls from high to low, high to low, high to low, high to low. So ಏನೇ ಡಿ ಎಲ್ ಇನ್ಪುಟ್ ಕೊಟ್ಟರು ಕೂಡ ಔಟ್ಪುಟಲ್ಲಿ ಅದು ರಿಫ್ಲೆಕ್ಟ್ ಆಗಬೇಕು ಅಂದರೆ ಅದು ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಅಕ್ಕರ್ ಆದಮೇಲೆ ರಿಫ್ಲೆಕ್ಟ್ ಆಗಬೇಕು. ಇಲ್ಲಿ 1 ಇದೆ, ಇಮಿಡಿಯೇಟಾಗಿ ರಿಫ್ಲೆಕ್ಟ್ ಆಗಲ್ಲ 1 ಅಂತ, 0 ಪ್ರೀವಿಯಸ್ ಸ್ಟೇಟಲ್ಲೇ ಇರುತ್ತೆ. ಆ 1 ಕ್ಯೂ ಔಟ್ಪುಟ್ 1ಗೆ ಚೇಂಜ್ ಆಗೋದು ಯಾವಾಗ ಅಂದ್ರೆ ಈ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಫಾಲ್ ಆಗಬೇಕು. ಫಾಲ್ ಆದಮೇಲೆ ನೋಡ್ಕೊಳ್ಳುತ್ತೆ ವಾಟ್ ಈಸ್ ದ ಡಿ ಇನ್ಪುಟ್ 1 ಇದೆ ನೋಡಿ. ಈ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಫಾಲ್ ಆದಾಗ ಕೂಡ ಡಿ ಇನ್ಪುಟ್ 1 ಇದೆ, ಆವಾಗ 1 ಆಗುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಫಾಲ್ ಆಗ್ತಿದೆ, ಆವಾಗ ಡಿ ಇನ್ಪುಟ್ ಏನಿದೆ 0 ಇದೆ. ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಫಾಲ್ ಆದಮೇಲೆ ಕೂಡ ಸ್ವಲ್ಪ ಟೈಮ್ ಡಿ 0ನೇ ಇದೆ, ಸೊ ಅದಕ್ಕೆ ಕ್ಯೂ 0 ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಫಾಲ್ ಆದಮೇಲೆ ಡಿ ಇನ್ಪುಟ್ ನೋಡಿ 1 ಇದೆ, ಸೊ ಇದು 1 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಫಾಲ್ ಆದಮೇಲೆ ಡಿ ಇನ್ಪುಟ್ ನೋಡಿ 1 ಇದೆ, ಸೊ 1 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಫಾಲ್ ಆದಮೇಲೆ ಹೈ ಟು ಲೋ ಫಾಲ್ ಆದಮೇಲೆ ಡಿ ಇನ್ಪುಟ್ ಏನಿದೆ 0 ಇದೆ, ಸೊ 0 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಫಾಲ್ ಆದಮೇಲೆ ಡಿ ಇನ್ಪುಟ್ ಏನಿದೆ 0 ಇದೆ, 0 ಆಗುತ್ತೆ. So the change of state occurs during the falling edge, and the negative edge triggered. So this is what called as a timing diagram of D flip-flop, which changes its state during the negative edge trigger. Okay, so coming with a rising edge trigger D flip-flop now. So if you want to construct a rising edge D flip-flop, you're supposed to write a circuit diagram like this. So this circuit diagram, if you want to construct this is a waveform for a negative edge trigger, means falling edge trigger. So if you want to deal with a positive edge trigger now, so you need to construct a circuit. Circuit looks like this. This is latch 1 and latch 2, two latches. If you want to construct construction of two gated D latches, we have a two gates G1 and G2. Hope you remember what is gate. Okay, depends upon the gate value whether we are going to decide whether the latch is active or inactive. Gate value, if it is 1, the latch will be active. If gate value is 0, the latch will get inactive. Latches. Okay, this is not gate, this is a clock pulse and a D input. We have two latches. Okay, hold together we call it a D flip-flop. Okay, so the same thing I have written here. Okay, so let me take G1 here. Okay, let me take D is equal to 0. Okay, So if D is equal to 0, okay, let me take the clock pulse is now 0. If the clock pulse is 0, so what will be here? 1. G is equal to 1. When G gets 1, this latch will get active. If G1 is 1 now, what will be the G2? 0 means, look at here, it will be 0. If this gets 0, this will be deactive. This latch will be deactive. Only this latch will be active. Okay. The left part will be active and the right part will be deactive whenever clock is 0. So whenever clock is 0, so we need to concentrate on positive edge trigger. Whenever the clock is 0, first part will be active and the next part will be deactive, because clock is 0, it will be converted to 1 by using NOT gate. So G will get to 1. If G is 1, this latch will get active. If 0 is passed to G2, if G is 0 here, this latch will be deactive. So whenever the left part of the flip-flop is active, the right part will be deactive. Whenever the right part of the flip-flop is active, left part will be deactive. So right now this latch is active, this latch is deactive. What is D value? D value is 0. So according to the truth table, whatever the value you are going to pass with respect to D, that will be the output. 0 pass mode is 0, 0 pass mode is 0, 1 pass mode is 1, 1 pass mode is 1. This is D flip-flop. So I am passing 0 here, D will be 0, so Q will be 0. What will be the P? P is also 0. So right now the value of P is 0. Okay. Now after this, the clock will be 1 now. Clock will changes to, okay, so now clock will change to 1. So if clock is 1, what will be this? This will be 0. So if this will be 0, this will be 0. This 0 means this will get deactive. So if this 1 comes here, this will get active. So it will accept the input. What is the value of P? 0, right? D2 is 0. Q will be 0. Okay. So this change occurs during when the clock gets 1. Clock gets from 0 to 1. Before it was 0, then moves to 1. Before it was 0, then it moves to 1. So moving from 0 to 1 is nothing but positive edge trigger, right? So this is a flip-flop which is going to work with respect to a positive edge trigger. Previous transaction which I just explained, by taking clock is 0, when the clock is 0, this part will be active and this part will be deactive. Okay, so I am just passing 0 and P will be 0. Only this part will be active whenever the clock is 0. When the clock moves from 0 to 1, like 0 to 1, this is a positive edge. Moving from 0 to 1 is positive edge trigger. Moving from 1 to 0 is negative edge trigger. Previously which I explained is moving from 1 to 0 here. Moving from high to low, this is a negative edge trigger. So we are concentrating on positive edge. So positive edge. Now 0 to 1 is moved. So this part of the flip-flop is inactive now. This flip-flop active will gets active. This 0 which was left P will be passed to D. So that will be passed to Q. Q will become 0. So 2 cycles, 1 complete clock cycle to pass D value to Q value. So the Q value is changed during the positive edge trigger. This is how it is going to work. So if I am going to pass 1 now. So when clock is 1, only this will be active. When clock is 0, only this will be active. So when the clock is 1, this part is active, right? So when this part is active, whatever the input you give to D, no matter what, it never takes into the consideration. This will be completely deactive. So right now, once it is high, again it will move from 1 to 0. Again it will move from 1 to 0, right? So clock will be again 1 to 0 now. So once it gets 0, this will be turned to 1 and this will be 1 and this will be 0. So now I am going to pass D is equal to 1. So this will be 1, P will be 1. Okay. Again 1 will be, clock will be 1 will be moved to 0. 0 means again, 0 to 1. So 1 means again this will be 0 and this will be 0. This will get deactive. This will get active. This 1 will be passed here. So D1 will be 1 and this Q will be converted to 1. So changing D input to Q input as 1, it needs 1 complete clock cycle. Change of state which occurs during the positive trigger. This is a circuit diagram. The same circuit diagram they are giving here. Clear? Okay. So look at this waveform. This waveform works with respect to the positive trigger. Okay. So what is this is G2, this is G1, right? G2 is active only when the clock pulse is what? Clock pulse is 1 0. Clock pulse is when the clock pulse moves from 0 to 1, getting when the clock pulse moves from 0 to 1, G2 will get active, second latch will get active. When the clock pulse moves from 1 to 0, G1 will get active. Okay, so look at here. So this is 0, this is 1. So both won't be active at the same time. Whenever G is 0, G1 is 0, G2 will be 1. Whenever G1 is 1, G2 will be 0. So completely opposite, G1 and G2, right? So look at the same thing here. So G2 is 0, so G1 is 1. G2 is 1, G2 is 0. G2 is 0, G1 is 1. So G2 is 1, G1 is 0. Completely opposite, G1 and G2. So what I told, whenever G1 is 1, latch 1 is active. Whatever the input you are going to pass with the D, that will affect only P, not the next, right? The same thing. So right now G2 is 0. So G2 is 0 means second latch is inactive. G1 is 1, so first latch is active. So whatever the input you are going to pass with the D, that will affect only P, first off, only P, not Q. So look at here, D is 0, Q, P is 0. D is 1, P is 1. D is 0, P is 0. D is 1, P is 1. So whatever the input you are going to pass, that is affecting only P, not Q, because only G1 is active, G2 is inactive now. So the Q, which is refers to the second latch, is completely 0. It is not performing anything here. Even though the major changes happening with respect to D and P, it is not affecting Q, because Q comes in the second latch. Right now it is deactive. Why it is deactive? G1, G2 is 0, G1 is 1. So G1 is 1, only latch 1 is active. So next, latch G1 will get to 0, G2 will be 1 now. So G2 will be 1 means second latch will active, first latch will be active, deactive. First latch deactive means whatever the input you are going to pass with D, it never takes into this latch. It never affects into this latch. See here. So D is 1, it is not affecting P. D is 0, it is not affecting P. D is 1, it is not affecting P. D is 0, it is not affecting, because right now this is inactive. So whatever the input you are going to pass with respect to D is not affecting P. So only the second part of the latch is active. So when this clock changes, what is the input here? What is whenever the G2 gets active, what is D value? D value is 1, right? So Q gets 1. So ಈ G2 ಆಕ್ಟಿವ್ ಆಗುವಾಗ P ವ್ಯಾಲ್ಯೂ ಏನಿದೆ ಅಂತ ನೋಡ್ಕೋಬೇಕು. P ವ್ಯಾಲ್ಯೂ ಅಂದರೆ D ಅಲ್ಲಿ ಏನಿದೆ ಅಂತ. So G2 getting active here. So look at D. What is D is 1. So P is 1. Don't look at P. Don't look at D. Look at P. When the G2 gets active, what is the value of P? 1. So that will affect Q. The P value will be sent to the Q. Similarly, so again G2 is getting deactive, G1 is getting active. Again look at here. So whatever the values you are going to pass, that will be affected D. D is 0, P 0, D1, P1, D0, P0. Okay. So again G2 will get active. So look at P. P is 0. So that is affecting Q. Getting. So this is D flip flop with respect to negative edge trigger, with respect to positive edge trigger. Okay. So then we have setup and hold time. What is setup time and hold time with respect to edge trigger D flip flop? So the same circuit diagram I have written. Look at this time, propagation delay. First we need to explain three things here. What is setup time? TSU refers to setup. Okay. TH refers to hold time. H refers to hold. TSU refers to setup, and TP refers to propagation delay. So here I just told the output will change after the clock pulse triggers. So this is working with respect to positive edge trigger. So you look at here, this is clock. So this moving from 0 to 1. This is moving from 0 to 1. So once it moves from 0 to 1, it will check what is the value of D. D is 1 here. once it moves after the clock occurs, after the clock positive edge triggered occurs 0 to 1 move admele, it will check what is the value of D. D is 1, so that will affect Q. So the input of D will be passed to the output only after the clock pulse occur. But D is 1 here, it never affects clock pulse occur agid takshana immediate effect agala. It never affects immediately after the clock edge triggered is occurred. It takes some amount of time. It takes some amount of time after the clock edge occurs. After it takes some amount of time to change the output based on the input. So what is that some amount of time? That is what we call as propagation delay. So after the clock edge occurs and the time duration between the clock edge occurs and the output change. What is the time in between? The output change and the clock edge occurs. Clock edge occurs yes, the output change yes. What is the time in between? That is what we call as propagation delay. So then we have setup time and hold time. What is setup time? Setup time is something like if the D input is 1 year, if it want to change to 0 here. D input is 1 year, if it wants to move from 1 to 0, before it moves to 1 to 0, before the clock pulse, it will set up. It will start deprivating. I means it will start moving from high to low. So high to low is something like it. If it is in the high state, it won't immediately gets down like this. Okay. So actually the waveform looks like this, but actually in really when you zoom it, it will be like this. It will start moving high to low like this in a slant manner. But when you look at the waveform, it looks like this. It won't immediately falls. It will fall like this. Okay. So it will start once it decides to move from high to low. The time. This time is there, no? That is the setup time. It will start to set up before the clock pulse. Before the clock pulse, the time before the clock edge occurs and the time from when the D decides to move from high to 0. So D ಇಲ್ಲಿ 1 to 0 ಮೂವ್ ಆಗಬೇಕು ಅಂತ ಡಿಸೈಡ್ ಮಾಡಿದ ಮೇಲೆ ಕ್ಲಾಕ್ ಎಡ್ಜ್ ಅಕ್ಕರ್ ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆ ಅದೇನು ಟೈಮ್ ಇರುತ್ತಲ್ಲ ಅದನ್ನು ಸೆಟಪ್ ಟೈಮ್ ಅಂತ ಕರಿತೀವಿ. ದ ಟೈಮ್ ಡ್ಯೂರೇಷನ್ ಬಿಟ್ವೀನ್ ದ ಕ್ಲಾಕ್ ಎಡ್ಜ್ ಅಕರೆನ್ಸ್ ಆ್ಯಂಡ್ ದ decision of D to deciding that it is deciding like moving from 1 to 0. So that is what is setup time. So after the clock edge occurs, immediately after the clock edges, it never changes. It will again take some time to change from 1 to 0. It will again change some time to move from 1 to 0. After the clock edge occurs, what is the amount of time it takes to change? That is a whole time. Before clock edge, what is the time it takes? That is a setup time. After the clock edge, how long it takes to change from 1 to 0? That is a whole time. How long it will hold in the same state before it is changing? That is a whole time. TH. Before the clock edge, what is the amount of time taken to set up to move from 1 to 0? That is a setup time. And TP. 3 things you need to remember. This is important. They might ask you if the question is for 8 to 10 marks, they might ask you to explain edge triggered, positive edge triggered D flip flop and explain what is setup time as well as hold time. They might ask the questions like that. So you need to remember this thing, okay? So next this is not that important. No need to go through this one, okay? If you are interested, you can go through. This is not that important. Moving on to the SR flip flop now.